Are you ready to the adventure in cryptography? It's going to be really short, half an hour adventure, no worries. Today, we have a really interesting topic to talk about, because I find cryptography interesting. And for the next half an hour, I hope you will pretend that you are interested in security and cryptography as well. So, my name is Anastasiia, and I'm a software engineer. Currently, I work as a product engineer in small cryptographic engineering company, Cossack Labs. Obviously, we create cryptography software to protect sensitive data in your apps, in your infrastructures. And I work there as, as translator, as someone who built a bridge between complex security world and demands of real engineers that are using tools. And today, we're going to talk about cryptography from an unusual angle. How to use it properly from the eyes of people who are developing cryptographic tools. Surprisingly, it's easier than you might think. Someone will say, starting with cats, right? So, someone will say, I'm a developer, I know that security is important, but I don't really know what to do and how to do. And as a security engineers, we try to make security products available and used by developers, and more developer-friendly. So when these two lonely cats come together, they start discussing and asking questions how to achieve our goals from both sides of barricades. Today, we will take a look on the typical workflow. Typical task you usually have. We have some sensitive data, and we need to protect it. Sounds familiar, right? I want to outline an approach that I myself repeated several times, and I saw my fellow colleagues repeat it as well. Mistakes that we make when we are trying to protect the data. So, the first question is how to define a data scope. What data do we have? What data do we consider as sensitive? Does our opinion about sensitive data correspond with regulations we have in our market? Well, GDPR, HIPAA, PCI DSS, and so on. You know that Apple has updated review guidelines, and now you must implement proper security features and protect user data. You must say and indicate what data do you collect, how do you store it, and what other third parties do you transfer the data. And by the way, since October, every application must have a public privacy policy available for everyone. So when we are defining the data scope, we must remember about that the data we operate in our app, in our system, and we often remember about business data. But we often forget about technical data, like logs, like some metadata that we collect, geolocations, exif tags, backups that we do or don't encrypt. The first mistake we make on our road of protecting data is a wrong definition of data scope. We just forget about things we shouldn't forget. How to fix this mistake? Well, you need to build the whole data flow for your application, for your system. You need to build the risk model, threat model, and write down the compliance regulations, not to forget about them. Now, when we are doing the second step, we are kind of define some data scope, and we are moving next. Let's say we want to protect the stored data. The easiest use case, right? We store something, we want to protect it. And of course, by protection, we mean encryption. Which crypto algorithm should we use to encrypt stored data? Any ideas? Sorry? Hey, you ruined my joke. Yeah. Basically none of them, because some of these algorithms, they are truly encryption algorithms, but they are old, outdated, known to be vulnerable. And others are hashing algorithms. There is no right answer how to fix this. So the second mistake we are doing, we are selecting wrong algorithm. How to fix this? Well, obviously don't use outdated ciphers. Stay in sync with progress. We are protecting sensitive data. We made just 2 steps, but already have several things to decide on. Let's move forward. Next step. OK, we selected the right encryption algorithm. Let's say it's going to be IES, right? IIS. Then we start digging into existing libraries, checking for Stack Overflow, and trying to find the code to copy-paste. Yeah, that's a mistake 3.5. This is an example of code. This is the OpenSSL code. This is basically encryption. It has tons of parameters, like buffer, buffer length, key length, init vector, padding, mode, etc., etc. Let's take a look at this. Do you know what is EVP, IIS, 256, CBC? That's obvious. This is CBC mode for IIS encryption with 20 to 156 bits as a key length. Third mistake we run into, we can select the right algorithm, but put the wrong parameters, just because it's not easy. Because most of you probably don't know the difference between IIS in CBC mode and IIS in GCM mode. And this is important, because CBC is known as old and vulnerable. And there can be other mistakes, like using the same init vector again and again, or forget about padding, or use the wrong padding. That may lead to Oracle padding attack. So things we should decide on when we are just trying to encrypt the data is growing. Next, during encryption, we have a key. And of course, encryption key is not the same as a user password. You know that, right? Pretend that you know it. And here we have a problem too. How to generate the encryption key? What key derivation function to use? How to store the key? Oh my God, how to transfer the key if we need? Should we create some kind of expiration procedure? Should we create some kind of key revocation if we find that the key was leaked somewhere? Well, you know, encryption is easy. Key management is hard. And this is the next problem, the next mistake we are doing. Even if we know what data to protect, if we know how to protect, which algorithm to use, which parameters to use, if we fuck up the key management, basically it ruins all the things. Because once you place the key near the data, it's the same as stored in plain text. So we have added key management procedures here to our list of things to decide on, and we haven't finished yet. Our product is, in most cases, is not a single application. It's the whole system, it's the whole infrastructure with different client sides, like iOS, Android, web, with the server side. Well, server side basically is a lot of microservices, database, or a lot of databases. Third-party dependencies like analytics libraries, some prediction mechanisms. And everywhere in our infrastructure, We have this encrypted data. We have a lot of keys. We have backups. Keys basically is everywhere. And the list of things to decide on, if we just want to encrypt the data, is continuing to grow. And you may feel a little overwhelmed. So, as users, what do we want? Do we want more ciphers? Like, having a cipher for each task we are solving. Like this, or like this, or even like this. That's so exciting. More ciphers, more protocols, more vulnerabilities, more patches. That's really cool, right? Well, that's exciting. But I'm looking into your eyes, and I don't see this excitement. To be honest, this is really exciting, but for crypto researchers, for people who are doing cryptography, not for developers. As developers, as users, we want a boring cryptography. Boring crypto is a concept proposed by Daniel Bernstein. Boring crypto simply works. It's strong enough to resist any attacks. It doesn't need any upgrades. Boring crypto is easy, like plug and play. Just turn it on and it's working. It protects you. Of course, it's a concept, some futuristic vision, but we have the industry is moving to that direction. So, most of you as developers, you are not interested in block cipher modes. I saw your eyes. IIS, CBC, and IIS, GCM. You don't really interested in that, right? Instead of selecting cryptography based on our knowledge about cryptography, we would prefer selecting cryptography based on the use case we are trying to solve, right? What kind of use cases we are solving? Like how to store data securely, how to transfer data securely, how to verify the data is coming from trusted source. However, of course, each high-level function is hiding a lot of crypto details there, with correct parameters, with key management procedures, but I believe that we as engineers don't need to spend time and focus on understanding cryptography. We need to solve our problems to protect user data easily. Let's take a look at the very beginning. Even building stuff sometimes is upsetting. This is how you get a boring SSL for iOS. Just by running pods try boring SSL, you will have the library being downloaded, you'll have the Xcode project to play with. Can you imagine, like one command, right? Can you imagine how it looks like for Android? This is only first command. So basically for Android, you need to compile boring SSL manually for each of your architectures. Then to merge, it takes some time. Then to merge compiled libraries into one fat binary. Then to integrate this fat binary to Android Studio and create your test project. Try to use the boring SSL and hope that it's working. From cryptography, we need something else. We shouldn't be scared away on the doorway. We want easy installation. Next, we expect a lot. There are no uni-platform products anymore. We have at least client and server is a bunch of stuff, right? That is running on different OSs and different architectures. So from cryptography, we want it to work consistently on many platforms without this suffering. Download, recompile, try to install it again. Download, recompile for your architecture, trying to install it. But we need a consistent, easy cross-platform availability. It's not about comfort anymore. It's a must-have feature. It's about reducing the risks of making mistakes, what we as developers can make during this recompiling cycle. But it was all about requirements. Right? We want this, we want high-level functions, we want it to be easy, we want it to be multi-platform. Let's talk about options that we already have. Let's discuss them one by one, starting from the most paranoid level to the easiest, to the less paranoid. How do you think, in terms of cryptography, what is the securest crypto system ever? Do you know what's that? Yeah, it's a dumb device without internet in a Faraday cage. It's really hard to break and hard to use as well. But from cryptography point of view, this is a really secure system. Unfortunately, we live in fortunately, we live in less paranoid world. We want something else, right? Let's get real. The ultimate security for encryption products are HSMs, hardware security models. They have separate computation environment. They can provide you keys, key generation, key storage, and they have minimal chances of leakage if you do things right. HSMs are used in ATMs, bank, data centers. TPM, Trusted Platform Model, is a bit lower grade of security. It gets integrated into your machine, so it exposes some internals, but yet it's kind of secure, and it's a trust anchor provided by vendor. TPMs and HSMs are really good. They work from cryptography point of view. They provide you a separation of duties and compartmentalization, which are core security principles. Talking in another way, running cryptography in isolated environment is kind of safe. Storing keys in isolated environment is also kind of safe, like super safe. What are problems of hardware security? That's bloody expensive. It has so-called vendor lock and unquestioned vendor trust. And you need to have each device on every machine that you are trying to run cryptography on. It's not easy to maintain, it's not easy to debug without vendor engineers. And if you're not a bank, it's probably, you might be challenged in having all these small devices in the infrastructure. So, when we are lowering paranoia level a little bit, we get to the software cryptography. This is what you think maybe when we are talking about cryptography, right? About software. It's not so bad. Flexible, friendly, available for your languages and ecosystems. However, there is no way to gain device trust that executes this code, which kind of okay for some architectures like mobile, that has safe execution environment, and if you're using iPhone, you trust Apple anyway. But things are not this good for web browsers. Literally, there is no way to figure out that code that you are running on web browsers is really safe. No matter how good your actual implementation is, browser itself, it's not a reliable way to execute a code. Fortunately, A lot of people are working on make web cryptography better, but it's still, right now, the results still don't satisfy the most paranoid of us. So typically, when we are working on security system, we combine best things of both worlds. We are using hardware cryptography where we can. Where we can't, we use software cryptography. If we can't put keys on the hardware level, okay, we should protect keys by some user-generated passwords, let's say so, or some other keys that are not stored in our system. Basically do as much as you can to eliminate the risks. I know that you want practice. I know that you're saying, hey, Anastasiia, we're iOS developers. What the hell are you talking about? We will have a bit of practice. So, summarizing, what do we want from software cryptography? It should be easy to install. It should be easy to use. It should work on all of our platforms. Of course, it should be proven, audited. Sometimes it's a must-have to be certified. It should have good documentation. But one of the important things is a form factor. There are three form factors. The so-called box solutions that completely solves your use case. Then crypto systems that solve your use case like partially. They implement some security guarantees that you need. And as a third step, we have the crypto libraries. Based on my experience using cryptography a lot, we want to stay as top as we can. By the way, do you see a point make your own cryptography here? No, because you shouldn't. Like, don't roll your own crypto. Don't think that base 64 is encryption, it's not. Don't use XOR as encryption, it's not. Basically, don't try to make up things yourself. Let's discuss those form factors one by one. Do you feel the difference between them? Is it clear for you what's the difference between box solutions and crypto systems? Mostly, we work with crypto libraries. But the crypto libraries are like the lowest grade in our, how it's called? Stairs, right. So this is the lowest stairs. Crypto libraries implement only some tiny security feature, like encryption or decryption, signing, verifying. There are plenty of libraries. You can check, by the way, awesome cryptography, you can check a lot of libraries there, out of scope of iOS development if you're interested. Here, I just provide some examples. I think you know most of them, do you? Yes or no? No, okay. So, CMIS is use case-oriented library for, well, all of them are for encrypting data, right? So, CMIS allows you to make it simple to store data securely, to transfer data securely. And it also has implementation of zero-knowledge proof protocol. Libsodium is a famous port of NHCL library, small and easy source of crypto primitives. Crypto Swift and around encryptor are probably familiar for you. Yes, Anastasiia, we know them. The noise protocol is a framework for building encrypted communication. Tink and Kitsar is a Google libraries. Well, of course, Common Crypto and Security Framework. This is encryption and decryption in Common Crypto. Can you guess what encryption algorithm are we trying to use here? Yeah, this is IIS, obviously. Which mode? Which IIS mode? you won't find out because there is no mode on these, in these parameters. Because by default, in Common Crypto, if you don't put mode, it's CBC. Easy, right? Not confusing at all. So CBC is default. But of course, you see here key, init vector, encrypted bytes. But don't be confused. Key, it's not a user password. Key, it's something that outputs of key derivation function. So before using encryption in Common Crypto, you should take your string, which you think is a key, and use a key derivation function to make it really cryptographic strong key. And again, we have a bunch of parameters here, like which KDF to use exactly, what algorithm to use, salt. Does it look boring? No. It looks rather interesting, but no, it's a lot of things to do. So achieving the same goal in 2 lines with THEMIS. THEMIS, this is IIS encryption in GCM mode, which is more strong, has more security guarantees as CBC mode. Do you see KDF here? No, because it's already built in. Do you need to think about key length here? No, it's already built in. THEMIS is using strong security defaults to avoid developers making mistakes. Does it look more boring? Yes. And this is a simple example. This is another example of THEMIS, only 1, 2, 3, 7, 8 lines that allows you to use secure transport between several nodes, between several applications, with mutual peer authentication, with key rotation. So the system is using ephemeral, using temporal keys on every session. All you need to do, just set up secure session, wait until it's established, and push any data you have there. That's all. It's encrypted, it's safe, only 8 lines of code. Does it look boring? Yeah, more boring than building it yourself from Common Crypto primitives. This was about crypto libraries. The crypto systems, they usually build based on libraries, then try to solve some user use case. Axolotl, it's OK. Do you recognize some of this? Yes. Awesome. Axolotl is a protocol for multi-user communication. Hermes is a framework for end-to-end encrypted sharing data. ZeroKit solves nearly the same and has integration with Apple CareKit. Well, SSL TLS, right? SSL TLS is a crypto system, and really good one. Again, some example of having end-to-end encrypted sharing of data in 1, 2, 3, 5, 6 lines of code. That's all you need to do to share some documents encrypted to user 1. The top stair in our stairs is a box solutions. Box solutions, they combine crypto systems and user functions. These are really complicated ones, but you use them quite often, like SSH. SSH is a box solution built on crypto system. Among others, do you recognize something? You should. At least I think you recognize SSH, TrueCrypt, and Vault. Say yes. 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 So, yeah, Vault is a key storage. Basically, they have HashiCorp has a lot of products built on the same crypto stack. Accra is database encryption proxy. TrueCrypt is used for managing containers. SSH, obviously. Again, how box solution work? This one line downloads and runs the whole database encryption proxy solution using Docker. Basically, it launches a PostgreSQL database, the proxy itself, it generates keys, puts the secure transfer between components, and up and running. One command. Does it look boring? More boring than it may be, that it might be if you do it yourself. So, if you have a security problem you want to solve, first step you do, you try to find a box solution that solves everything you need. Then, if you don't find one, or if it doesn't solve all you need, you do the step down, looking for a crypto system. Only then, you are reading GitHub, Stack Overflow, and try to find the library. Because each step down means that you need more and more efforts and time to implement and to support your solution. This is your decision map. What's the most important point here? Yeah. All of them. Right. But yeah, first one is like a crucial one. Don't use it if you don't need it. So, let's wrap up. We and the world around us, we don't have any problems with crypto algorithms and ciphers. We have them a lot. But the algorithms themselves are not a problem. The problem is that they are really complicated to use. Using them requires a lot of efforts and time and leads to making mistakes. Do you know what is it? Sorry? Lantern. Yeah. Well, this is oil lamp. If you remember, your grandmas and grandpas probably had some oil lamps. In different regions, people had different types of oil lamps. They did them themselves, they buy them somewhere, and they were using different kind of oil, and they were using different kind of wick, these threads. And every evening, you needed to go through all those lamps and to fire them if you want to turn on light. Do you know why Edison lamp became so popular? It still requires resources. It still requires you to use the lamp bulb and electricity. But it's much easier to use. Edison made light controllable. It's easy to turn on and off. It's easy to find suppliers. What common do Edison lamp and modern cryptography have? What do we want from cryptographic libraries? Actually, pretty much the same. We want usage of cryptographic libraries to be predictable, controllable. We want it to be boring when we are using them. So, today, we talked about how complicated it is to solve the typical use case of protecting user data. What kind of mistakes we as developers can do during this process, starting from defining their own data scope, selecting their own algorithm, putting their own parameters, copy-pasting their own code from Stack Overflow, forgetting about key management. But all these things can be solved in other way. There is a hardware cryptography, software cryptography, web browser cryptography. If you want to solve the security problem, you should start from searching for existing boxed solutions that already solve your use case. If you didn't find one, try to find a crypto system. Usually these are protocols, ready-to-use protocols. If you didn't find one, try to use the crypto libraries. Pay attention how boring is it to use them. Did they Is it easy to use? Is it easy to install? Is it hard to misuse? How many platforms it supports? Because all of this decision map is actually impacts the time and effort you spend on implementing security in your product. I know that you are super interested in security. I see it in your eyes. And I see you asking, Anastasiia, please tell us what to read. I have an answer for that, of course. A lot of links for your home reading. Even more links for your home reading. No worries, all the things will be in slides online. If you want not to read, but to see my other talks, some talks to see, they are online on GitHub. Thank you for listening.